Hello everyone. In this video I'm gonna make a very critical mistake. Would you be able to catch it before I make the correction or tell you what's wrong in it? Please mention in comments. Thank you very much and have a great day. Hello and welcome back. In the previous video we solved this problem using the beam elements. Now we want to try it using the 2D plane stress elements, and we will be solving it in two different problems where we first define only the constraints on these edges, and in the second video we will create these pins, and then we will use the frictional contact between these two. So one would be a linear problem and another one would be a non-linear problem, and then we will see how the results would be different in both ANSYS and Abaqus. So we start in Abaqus using a part, and now we want to use a 3D element with a shell that is planar and it would have some thickness. So let's create a 48.750 and then since it's arbitrary, so we can change it anytime later on. And we first need to create a, this is the center point and it highlights it. Oops, I'm gonna hit escape, and now we get a reference this dimension to be 48. Let's make it like 50, 2-inch more than that, and now we can split it. And as you see that this one was about center, so the other side is already 50, and now I can hit escape and then convert it to construction, and I can do that by clicking this and done, and now I have a plain thing. And but the important thing is that I have to, yeah, I still have to create a partition in, and then we create it by using a sketch and select an edge or axis that will appear vertical and on the right. Let's select this one and then we can start sketching. So we have first vertical line and then the second one and then the third one. So it has to be 48 from the center, but it's off center anyway. Now we need to put a constraint coincident. It doesn't give any point. Now we need to put a point here, and we need to fix this point. Done. And now we need to put coincident, and so can we drag it like this or the other way? Now we need to put this dimension as 48 as well, and we have this partition geometry. These edges will be important, these points, but here what we did not see yet is its thickness, like what would be the thickness of it. So let's create a material. The material was inelastic 1.6 high power 6 and then 0.3, and now we create a section that is solid and homogeneous, and then material 1, and then plane strain, stress, strain, thickness. Now here we put 6, which was our width, and then we hit OK, and then we go to the assembly and put part in it, and now we select the boundary conditions. So we hit this point and this point, and we're gonna fix everything, and the other boundary condition on that point, not on edge, it's on point, and just fix y2. So we're going to create a step where we can apply this boundary condition and let this one be non-linear, linear. It's -3, and but it's important that we have used the upper point because it's being applied on from the upper side. And let's create a job. What did we miss here? We forgot assigning the section and applying the mesh. So we need to select all of it and then apply the properties, section properties. We didn't create a section yet. So we created a section that was 3D homogeneous, but it can't be applied to it. Because it's a shell. Now we need to create a shell that is homogeneous, and its shell thickness is 6 inch, and it has the material as material 1. And now we can apply the section 2 to it. Section 2, middle surface, and hit OK, and done. Now we're gonna go to mesh, and it's red, weird. So we select the mesh size to be 1, and then hit OK. So let's try the results now. Let's write input, submit, and we just submit it. And we check the results now, and obviously it's going to be wrong. And can you guess why? Because we didn't put the thickness correct. And let's go back and check it again, what we did or that we missed. Section sketch, and it was supposed to be 0.5, and now we hit OK, done, OK, and regenerate, and now we submit it again. Yeah, it's unmeshed. Let's see, why is it showing red? Quad and free structured. Delete, and then it's done. Okay, yes, and maybe we wanna put a more refined mesh, but we will see later. Let's submit it now and try again. Now let's check the results and see if they make any sense or they are in comparison. So the stress that we have now is 16 psi, and that is obviously over here on the boundary, and the RF, that is 14.9. that is very high on over here, but it should have been high over here. So let's try the mesh again, and then we can see. Maybe we can just put a little bit too much stress over here. Mesh elements. Maybe we just put it number of elements 4, and even on the other side as well. 4. And now we create the mesh, and we want to refine it to, let's say, too much. So it doesn't matter for now what the size is, but we just want to, we just don't want to lose the accuracy. So let's check again that we did -3" and everything should be in inch. And what we have here is the material is 1.6 high power 6, that is correct, and 6" and 0.5 and 0.5. It was 48 on the split one, and in the section we defined we created and in the section we created a thickness of 6 mil. So one more thing that we did it again wrong is to suppress everything. The pin should only be in vertical direction, and it should, and the other one is in vertical direction as well. Let's submit it now and then we can try. Let's check the results now, and the stress now is 1465, which is highest over here, and let's check it if it is still high on the boundary, and that is no. So now we have good results, and maybe we can check it with on average results, and check the results on the edges, and that way we can hide the mesh elements. So if it is on average, it still has some error because these they still don't have the same colors or the same band. And check the force. Now force is 16.2, that is highest on the point where the boundary is applied. Now 16.2, and it is 16.28, so it is in correlation with the force, but the stress still needs to be good. And the one reason could be because the mesh is more slender rather than more cubes. So could it be the reason? We don't know. Let's try it again with refined mesh, and then we can check it. So for that purpose, I'm gonna remove these edges, mesh control, and then so they can have the same size and for mesh, and click OK. Now they're gonna become very small and too many elements, but that's fine because we want it to be very accurate. And let's submit now, and then we check the results again. Now this problem used way too much resources, and it took almost like 13 GB RAM and a little bit too much time to solve. And let's see the results if they are in comparison. Yeah, so we have the stresses are 1573, which is good. 1573, a little bit more, and RF is 16.269, which is like very in comparison with. So it's a very tiny element, and on the node in fact, and we can still see the feature edges, and then remove the mesh, and now we can see the stress as well. stress and no, there still are two elements that are not in the band. Yeah, it's unaveraged, but it still looks good, and we can still experience the this region that should experience the zero stress, and and the highest stress should be on the outer edges, like the bending stress. So what is bending stress here? And that should be 1 yeah, 1529. Now we can see like which is due to the compression, which is due to the tension, so because of the colors. Now as we can see, the neutral axis and the edges that have the highest stresses, we can still check out for the where the force direction is highest. And no, let's see where the moment is highest. No moment, because we didn't fix any moment, right? So the only force that is available is the vertical force. Now let's try, let's check out how much time it took for the computers to solve this thing. So the total CPU time is 148 seconds, and this is for the 2D problem or the 3D shell problem. It's not a 2D plane stress problem, because when we created the plane stress elements, it didn't really happen to us. So we created a 3D shell mesh, and which is really the 2D thing, and but it has the thickness that is used in the section and not in the model. So it's still a 2D problem within the 3D boundary condition. So when we use the beam elements, it just took like 4 seconds to solve it. And when we use the 2D elements or the shell mesh, it created 148 seconds. It took us 148 seconds. Now this is the difference that you should mind when you're creating an FEA problem, and it can make all the difference. Let's try and create the same problem in ANSYS using the previous problem. So we are just linking the previous engineering data with um, with the material properties that we used in the beam problem, and we're just gonna use it. And let's create a 2D geometry, and then we will create a 3D out of it. So let's create a problem in XY plane, a sketch, and it should be like this, and create a rectangle that is like 50-inch. That is horizontal, and now this size is not too much. We need to create an inch, and it has to be 48 inch. Let's create 50 inch again. 50 inch, and this is 50 inch, and this thickness is vertical, and it should be 0.5 inch. And now we can move these dimensions to have a look. Now this is our model, and we need to create a surface from sketches and select this sketch, and its thickness is going to be 6 inch, but we would still have to add this thickness to be 6 inch in the meshing or the workbench or the structure. So now we have a surface body, and we are ready to go into the ANSYS. Structural. So let's go to the meshing, and as you can see, we can notice a question mark over here. Something's wrong, and the assignment is A1, and the thickness here it is going to be 6 inch. It has to be like 6 inch, right? Now we are going to have, we didn't partition it. Like in ANSYS, this is the problem, that you cannot partition it or play with it once you have it here. Now we're gonna go back to design modeler and then partition it. So let's partition this face. So we have a face split. Maybe we can use it using the sketch. And but before we do that, we need to create a sketch. So let's delete it and create a sketch over it. But let's hide it first, hide section, and then we need to create another sketch, and that should be on top of it. So let's create an arbitrary line over here and one in the middle and one over here. So let's first try and then see if we can make the split using the sketch. Target face and tool geometry, sketch 2. Oh, oops, we cannot, but we still need to delete it and then try with something else. So can we create a line from edges? Oops, we need to create line from sketches. Add frozen, and now we hit it. Now we have 4 line bodies, and maybe now we can face split it. So we have the target face and then tool geometry. Can I use these bodies? No. So by straight line, I still cannot use it, or maybe I can still use the sketch. By plane or by surface. So what we need to do, how we can split it. So let's try with, we have the boolean and split the edges, and can we use the fractional split by delta and location? I don't know. Maybe the only choice we have is just to create this end with the 30, or sorry, with the 48 inch. Like we should not exceed our limits. And then we can split this line into 2 split edges, these 2 edges by 0.5, and then we get a midpoint. Now we have the surface body and this thing. Now hit generate, and then we hit update geometry, and now we would be good to start with. So with the remote boundary conditions on these 2 points, like we did in beam, and it wasn't much success though. But let's try it now, and then we can only fix the y, and where would be the other point in the middle. And now we're gonna put another boundary condition, displacement at -3, that is -3 inch. So now we have only fixed the y y degree of freedom, or y, or motion in y direction. Let's try it if it runs. Okay, mesh is relatively coarse, and but we first need to understand the stability of it. Like, would it run or would it not run like the beam? Yeah. So we have a solver pivot errors, and it's not gonna work. So let's fix just the displacements, and or maybe let's fix first try it with it, and then we can see. Yeah, we still have a problem, and not enough constraints appear to be applied to prevent rigid body motion. So let's fix everything, and give the meshing to be very small. How much did we do in? So it's 0.01. That should be the same that we did in Abaqus, but one thing is that in Abaqus it uses linear elements, and we also gonna use linear elements here. Element control manual and linear element order linear. Now we hit generate so that we can have the same nodes and elements that we have in Abaqus. In Abaqus, what do we have as mesh? So we applied 0.01 inch, and in ANSYS we applied 0.01 inch, and elements and nodes. Well, that's way too much elements. 500,000 and 510,000 and 51. So let's see if we can see the same numbers in ANSYS as well. It's gonna take a little while to mesh. But the ANSYS didn't take this long. Sorry, the Abaqus didn't take this long. We can still try it. Now it's been like 5 minutes and ANSYS is still meshing. But I said we're still gonna look for some problem in it. Maybe they just created too many quads or triangles. But 5 minutes is way too much. Now I'm gonna stop it because it's been 5 minutes, and it's I don't know how much time it's gonna take. So let's give it a body sizing of like, but it's so weird, like it shouldn't take this much time. In Abaqus I just pointed 0.01 and hit OK, and now we create mesh, and done. We have a good mesh, but it's crazy that it's not making this much. Now let's try with it, and we generate mesh, and it's done. Now let's point 1 and we generate and see. Yeah, now it still needs to be less than that. So let's try it. Let's clear it, and maybe there is a problem for method and quadrilateral dominant. Quad or try and hit generate, and let's see how much time does it take. Now ANSYS took like 2 minutes to generate this mesh. It's relatively coarse as compared to Abaqus, but I don't want to spend too much time on meshing and not have it solved using So we apply these two boundary conditions, and let's run it. The results are obviously going to be wrong because we cannot just make like support as a pin. And there we go, we have the stress and how much it is, like 3.8, and it's way too much. So what about the force reaction? Where do we have the highest force? Like, yeah, 0.5. Ooh, minus 3 inch, minus 3. Okay, the force reaction is 64 because we fixed everything over here. At this point we fixed everything, and that's why we have so much force that is going and so much stress. But let's see if we can find out the neutral axis over here. No, because the the mesh is still very coarse, and it's showing too much stress over here, and it's not a complete beam model. So we're gonna refine the mesh again, and maybe the very refined, let's convert it to a little bit more refined, and then we can try with it. Now it's been 3 minutes, and ANSYS still has not finished creating the mesh. I'm not sure if I'm gonna leave it like this or should I wait. For this simple problem, it's too much waste of the time, and I'm just gonna stop it and see if I can see the previous one. um, Defeaturing, maybe it's because of the defeaturing. Mesh defeaturing, no. And growth rate adaptive, no. Linear element size is body 0.05, and quad dominant. Let's read with multi-zone. Maybe that would end up having the good mesh. Yeah, it created a mesh very fast using the multi-zone method, and let's do it with 0.01. And now we hit it. Now it shouldn't take too much time because it just quickly create the mesh with the 0.05. But it's still going on. Now, this is weird. So if I put it 0.05 and I hit generate, yeah, it's done very quickly. Let's try it half as much, and now try it. Again we have the same problem. Meshing is taking too much time. The following entities with objects scaled to them were unable to have mesh data. Now which one are these? It's the point. Okay, let's run it and then we can see. Now we cannot run it. Load transfer has occurred. D feature. The load could not be applied to small or defeatured edge. This is something really crazy. Like maybe it's because of the defeaturing thing. mesh defeaturing, yes. And let's try it one last time and then we can conclude it. Yeah, something is not right here. So this point apparently is not having a good mesh. Try another mesh method to get a successful mesh. Let's delete it and then we can try it. And maybe now it takes too much time. We don't know. But I think it's a good time to conclude it and you can try experimenting with it. And I don't want to waste too much time on it because it's a very simple problem and it should not take this much time, and it's a sheer waste of computing time and energies. But nevertheless, when we use the 3D problem and we use it through the shells, it has to be properly defined, and it gave us 148 seconds with the shell mesh and 4 seconds with just the beam problem. Now if I have a truss, I rather would like to model it with beams, or if I have a structure that needs to be modeled, I would rather have it modeled in beams elements rather than having it in 2D or 3D shell mesh. So yeah, it's still creating the mesh. That's too much time. So let's finish it and then we can try it using the 2D plane stress problem. And remember, in the start I said that it's a 2D plane stress problem, but uh, we ended up having a 3D shell mesh because we had a 3D problem over here. It's 3D, not a plane stress. And even you can see it here that the problem is thickness and thickness mode, refresh and update, offset type, middle. Now we have a mid-plane surface, and and it's not a 2D plane stress. And that is the same in Abaqus because we created a 3D part. Oops. Now this part was a 3D deformable part and not a 2D part. And its thickness we defined in the section. So let's try creating the same problem in 2D plane stress problem, and then we can see if we get the same results. Thank you very much and have a great day.